Welcome to Math Challenge 434. In Math Challenge 434, we have a square, a quadrant blue in color, that's a quadrant or a quarter circle, and a small red circle. We have one square. Inside the square, we have a quarter circle or a quadrant blue in color, and we have a full circle red in color. And we have to find the radius of the small red circle. Welcome to Math Challenge 434 for junior and senior Olympiads and for all competitive examinations. Each side of the square is 5. That's given. It's given that the square, each side is 5 units in length. So that is the radius of the quadrant. So the radius of the blue quadrant is also 5. See, we have marked it horizontally and vertically. The left bottom corner being the center of the quadrant. The radius is 5 units for the blue quadrant. So let bottom left vertex of square, also center of blue quadrant be O. So now we are marking this as O. So from O, horizontally and vertically, the radius of the quadrant and also the side of the square is equal to 5 units. So we got radius of blue quadrant equal to 5, and also O is the center of the quadrant. Draw diagonal OX. X is the top right corner of the square. We join OX, which forms the diagonal of the square. So we draw OX, which forms the diagonal of the square, and let us see whether we can calculate OX and relate it to the radius of the red circle. So we got the radius of the blue quadrant 5. Now the diagonal, we join OX. X is the top left corner. So we get the diagonal OX. The length of diagonal of a square is given by root 2 into side. So here side of the square is 5. So diagonal OX, root 2 into 5, that is 5 root 2. So length of diagonal OX will be 5 root 2. Now from the center of the red circle, we draw two radii, one vertical and one horizontal, to the sides of the square, and in fact the sides of the square are tangents. The sides of the square are tangents for the red circle. So we draw two radii, vertical and horizontal, from the center of the red circle. So we got diagonal OX is equal to 5 root 2. Now see that the diagonal OX is made up of 3 parts, 3 segments. One is the radius of the blue quadrant. You can see the red line, the radius of the blue quadrant, which is 5 units. Second, the dotted line, that is the radius of the red circle. The dotted white line, radius of the red circle, that is R. And the finally last part, the black line, the black solid line, which is the diagonal of the small square, and each side is R. So this diagonal will be R root 2. So the diagonal OX, which is 5 root 2, is equal to a radius of the quadrant 5, that is the red line, plus radius of the red circle, that is R, and diagonal of the small white square, the black solid line, which is R root 2. So the total 5 plus R root 2 should be equal to the diagonal OX, that is 5 root 2. The diagonal OX from O till the boundary between the red and blue arc, it is the radius of the blue quadrant 5. The white dotted line, that is the radius of the red circle R, and the final part, the black solid line, is the diagonal for the small red square, each side equal to R, that is the radius, each side equal to r, so the diagonal will be r root 2. And adding these three, we should get the diagonal OX, which is 5 root 2. So 5 plus r root 2 is 5 root 2. So we got 5 plus r root 2 is 5 root 2. Transpose 5 to the right side. So r root 2 plus r will be 5 root 2 minus 5. Take r common. On the left side, r bracket root 2 plus 1 equal to, take 5 common here. On the right side, 5 bracket root 2 minus 1. So r will be equal to 5 into root 2 minus 1 divided by root 2 plus 1. Now to rationalize, we multiply the numerator and the denominator by the conjugate root 2 minus 1. So in the numerator, 5 into root 2 minus 1 whole square, and in the denominator root 2 plus 1 into root 2 minus 1, which is root 2 whole square minus 1 whole square, which is 2 minus 1 equal to 1. So the denominator becomes 1 and the numerator 5 bracket root 2 minus 1 whole square. So this is the radius of the red circle.
Was that interesting? If you have any other method, we would love to learn from you. We shall come back with more interesting videos. Like, share the videos, and subscribe to our channel if you are a math lover. Till then, goodbye.